Now that you know about resting membrane potential, let's see how we have a signal in a neuron. First, we're just going to focus on the axon, so the conductive segment. So from here to here. So we're starting off with the whole neuron in resting membrane potential. Now remember, a signal starts up here at the dendrites and cell body, and it moves through the axon, and then down to the telodendria, and then this last part is the synaptic knob. We eventually will learn what happens in each of these parts. But right now, we're going to see what happens in the axon. So at the start, at resting membrane potential, you are at -75 for the inside of the axon. And you have most of your sodium outside, and you have most of your potassium inside. In order to have that action potential on the axon, you have to move the ions in and out. So sodium will move in, and potassium will move out. And that's what makes the electric signal. This picture is just showing again, sodium goes in and potassium goes out. And when sodium goes in, then potassium goes out, you have a signal. Here we can look at it in more detail, and we can split it up into 6 steps of what happens in order to get a signal going through your axon. We're going to start off, here's our voltages. So this is -75, our resting. The dotted line is -55, which is threshold. Up here is +30. So those are the 3 voltages we're going to deal with. So we begin step 1. You're at resting membrane potential. And at this time, we know that potassium is in and sodium is out. Step 2 is this part right here. Let's go ahead, we'll color code that. There's step 1, here's step 2. Step 2 takes place in the hillock. This is when the hillock is doing summation. So the voltage is raising in the hillock. If it raises to at least -55, it will cause an action potential in the axon. So remember, we said the hillock is the initial segment. It's like when you hear a rumor and then you have to decide if you want to pass that rumor on. So right here is the hillock deciding to do that. Then step 3 is depolarization. So the voltage is going up. So this is when the sodium gates open. And when they do, sodium comes in. Now you have potassium in, and you also have sodium in. So because both of your positive ions are inside, this raises the voltage to positive 30. Next is depolarization. And this time, the voltage is going down. I'm sorry, repolarization. So now the potassium gates open. And potassium goes out. So now we have our sodium is in and our potassium is out. So because the potassium is going out, a positive ion is leaving, the voltage goes down. The next part here, see we have this dip kind of below your resting membrane potential. That is hyperpolarization. Okay, remember that hyper means more. So this means that it is more negative. So think about how you would get it more negative. We got it to go negative by letting a positive ion out, the potassium. You get it more negative by letting extra potassium out. So during this time, the potassium gates remain open and extra potassium goes out. So now we have our sodium in, we have our potassium out, and we have extra potassium out, which makes it extra negative. Then the last part here, we return to resting membrane potential. Remember the pump and the leak channels? This is where they come in. They put everything back to their starting positions. And your voltage returns to negative 75. So now we have our sodium back out, and we have our potassium back in, and we're back at negative 75. So there's an overview of how you have that action potential in the axon. And steps 3 and 4, depolarization and repolarization, these two steps together are considered an action potential. So whenever you're talking about action potential, that's what you're talking about, depolarization and repolarization. And that is the signal.